Anyway, tonight we're going to talk about Grand Canyon's awesome geology, this awesome abyss called Grand Canyon. And most of the visitors to the Grand Canyon have a view of the canyon looking at it from the rim. And this is the view that most of our visitors get. If you go out here to Desert View, there's a great view of the Colorado River. Many of the viewpoints here in the village, you don't actually see the river. The gorge is so deep that you don't see it. But about 1% of the park's visitors actually get a chance to backpack down into the bottom of the canyon and spend the night on the ground down there. And then there are also a number of people who get to enjoy a river trip in the Grand Canyon. And let me just tell you that if any of you ever have the chance to come back and explore Grand Canyon a little more deeply, pun intended, getting on one of the trails or going on a river trip is really one of the finest ways to experience this fantastic place. So I'm just going to start off here with a few details about what is so spectacular and awesome about it. You can see this view from the air. This is a view of the Butte Fault. There's not a whole lot of faults that run through the Grand Canyon, but the ones that do are spectacular. And there's the trace of the fault right there. And all of the rocks to the left of that red line have been uplifted about 2,500 feet relative to the rocks you see on the right. And what's spectacular about this fault is that when those rocks on the left were shoved upwards, they took the flat-lying strata and they bent them up like that. And that's what you're looking at in this ridge right here. These are very old rocks behind the arrow, and they're sitting next to rocks that are very young right there next to them. We have these huge mega landslides in the Grand Canyon, and you see a lot of these very well from the river. As you're looking downstream on the Colorado River right here, it looks like the river is running into that wall, and that wall is where a giant failure happened on a cliff, probably sometime during the Ice Age, and there's that rubble laying there, and it buried in a channel of the Colorado River. In fact, this is one of my favorite mega landslides right here. Again, the river in the lower part right there. And the landslide came down and filled in an old channel of the Colorado River. And I'll just highlight that for you right there. That's where the Colorado River used to go, was through there. So if we remove the landslide, that's where the river used to go, was right through there. And that landslide came down and filled in this whole space right here. Then the river had to carve a brand new canyon right over there. And there's currently some researchers from the University of New Mexico who are working on this landslide to try to get dates for it. And preliminary dates for this are about 900,000 to 1 million years ago when this slide came down and blocked the river. By the way, I might forget to mention it. So I do want to mention, while I'm thinking of it, the Colorado River has a motto. And that motto is "No obstacles allowed." Anytime an obstacle is thrown in front of the Colorado River, it almost instantaneously takes care and removes it. There you see that landslide filling it in there. There's extreme erosion in the Grand Canyon. This is another late afternoon shot. Here's the course of the Colorado River here. Navajo bridges crossing it near Lee's Ferry. And look at these side canyons that rarely have any water in it. And yet they've cut canyons that are about 50 to 100 feet deep as they pour over the top of the Grand Canyon rim. We have lots of deformed strata in the Grand Canyon. This happens before the canyon was carved. These rocks were deeply buried and the Earth's crust would be squeezed together, and these layers are now deformed. You can see these yellow lines highlighting what started out as horizontal strata. And due to these compressive events, this strata gets bent. Probably at depth there is a fault that is pushing up on that strata, and that's what causes it to be deformed. But I think one of the most spectacular things is that in the western Grand Canyon, we have these wonderful lava flows that have erupted in the last 800,000 years and have spilled down into the Grand Canyon. Imagine what it must have been like to be here during the Ice Age. The river probably had more water in it then from the increased precipitation in the southwest. But on numerous occasions, lava would spill over the rim of the canyon and fill in side canyons. And you can see these lava cascades as they make their way down from the rim. And in many instances, these cascades piled up many hundreds or even thousands of feet along the river channel to create lava dams. And here's one right here. You can see this cascade coming down, and right there you can see where the top of a lava dam would have been. Everything down here that's now been re-excavated, this would have been solid lava blocking the course of the river. So let's just have that hot lava pouring down into the canyon right there and forming a lava dam. On at least 13 different occasions, the river was dammed by this lava. In one instance, there was a lava dam that flowed downstream 84 miles. We find remnants of that single lava flow 84 miles from where it entered the canyon. This is another lava dam. The river is in the shadows right there in the foreground, flowing from right to left. And this huge wall right here used to be continuous lava across the channel of the Colorado River. You can see these fantastic cooling features called columnar joints. When the lava cools, it contracts into these 5 or 6-sided columns, and they look like they're just peeling off the side of the cliff when you go by on the river. And then we have this one place where there's a volcanic neck sitting right in the river channel. This is called Vulcan's Anvil, and Vulcan's Anvil is the conduit or the throat of a volcano that erupted right in the channel of the Colorado River. And probably there was a large cinder cone that was built across the river's channel, possibly even a lava dam right there. This is really exciting when you float by this, and this is just some of the real exciting geology that can be seen here. I would say that Grand Canyon's geology is awesome. And by the way, any of you that are visitors here, you've probably come to Grand Canyon to see the scenery. Let me tell you that scenery is code for geology. When you talk about scenery, you're talking about geology. People come here to look at these colorful rocks, the way they're shaped, the beautiful forms. This is all a geologic story. So there's 5 factors that work in concert to create the Grand Canyon. And if you remove any one of them, you would not have the Grand Canyon. The first is that we have a very thick stack of sedimentary rocks. That's not the only kind of rocks that are here. We've seen volcanic rocks. There even are metamorphic and igneous. But the real stars of the show here is a thick stack of sedimentary rocks. They're not just any old sedimentary rocks. They're variably and brilliantly colored. And if you've been to the Painted Desert or Arches or Canyonlands, you've seen these colors in the rock. Another key thing is that all of this area known as the Colorado Plateau was uplifted gradually such that the rocks were not largely deformed, faulted, or folded. So a giant layer cake of strata has been uplifted into the air. This stack of rocks is carved by a large river, and that's not too unusual, except when you look at the 5th factor. All of this is set now today within an arid environment. And with apologists to any botanists who are in the audience, at Grand Canyon we do not have much of this bothersome vegetation which only serves to cover up the geology. And of course I'm kidding, because Grand Canyon is a national park that has more plant species than any other national park. There's about 1,800 plant species, so you could come here and call Grand Canyon an all-star park because of its botany. But set within an arid environment, we do not have any of this vegetation covering it. There's actually a more geologic reason for that. If you took any of our limestones that are out here, like the Redwall limestone or the Kaibab limestone, and put those same deposits in a humid environment like we have in Brazil or the Congo in Africa, those limestones would melt away. You could not have a landform like the Grand Canyon in a tropical environment. So this last one here is very, very important to be in the creation of Grand Canyon. And of course, having a large river in an arid environment might seem mutually exclusive, but the Colorado River has its headwaters in the Rocky Mountains, where as much as 70% of the water comes from the Rocky Mountains. So if you're thinking of giving a lecture yourself after being inspired by this talk tonight, you could mark down 2 major landforming episodes that we only need to talk about. The first is the deposition of strata. This is the creation of the rocks. This is the much larger part of the story. This is hundreds of millions or 1,000 million years. And we're going to deposit that strata from bottom to top. That's what geologists do. Layers at the bottom are older, and you just sequentially bury layers through time. And then the second part of the story is the sculpting of the land, the carving of the Grand Canyon, if you will. And we carve the landscape from the top down to the bottom. So there you see the Grand Canyon carved. And if you walked away and said you only learned one thing in the talk tonight, it would be that there's two parts to the story, the creation of the rocks and the formation of the hole in the ground. One thing that people might not realize is that sedimentary rocks leave a record of the environment in which they were deposited. So when you go out and look at rocks like this orange shale right here could actually be ascribed to an environment that all of you are familiar with. Maybe a sluggish river like on the Missouri or the Mississippi. And this cliff of sandstone right here could be ascribed to an environment like we have in the Sahara Desert. And a little secret that geologists don't share with people is that when you walk to a rock outcrop like this and go to interpret it, how it was deposited, there's not thousands of choices that you have to choose from. There's really only about 10 or 12 or 14 possible environments that a rock layer can accumulate in. And geologists don't want you to know that because they want you to think that they're really, really special, like brain surgeons or something. But, you know, a lot of times I will go to a rock outcrop and we'll say this was deposited in a shallow sea. And somebody's bound to say, how do you know that? It looks just like the rock that's sitting over there. There's not a whole lot of environments to choose from. And look at this deposit here. This deposit is only about 10 years old now. Unfortunately, it's been destroyed when the bulldozer came in. But here's an example of a deposit that was laid down in August of 2005. Even if we didn't know when it was laid down, we know that it had to be laid down after 2001 because that's how old that car is. And you can't shove a car underneath sediment. You have to have sediment being deposited on top of something. So that deposit is younger than 2001. But the most important thing is look at the architecture and the structure of the sand that's in here. Now we know that this deposit was laid down in a hurricane surge. You can see the high water marks on the tree over here. There was actually water that completely buried this car and that house behind it. So if you went to a deposit that was completely lithified, solid rock, and you saw the same type of structure, you could make the interpretation that maybe that deposit was laid down in a hurricane surge or something like that. That could be one of the possibilities. And this is how this works. This is how we know what all these environments were. So here's the giant stack of rocks that we get to enjoy on the Colorado Plateau. The bottom of the Grand Canyon is right here. That's the bottom of the stack. And there's about a 3-mile stack of sediment that goes all the way up here. There's the rocks at Bryce Canyon National Park. And at Grand Canyon National Park, these are the rocks that we see. Here at the Shrine Auditorium tonight, we are at this stratigraphic level, and the canyon goes 1 mile below us. And when I'm on my guided hikes with the Field Institute here at Grand Canyon, we walk the 8 miles up the canyon wall here, and we get to the El Tovar Hotel and the ice cream shop. And I pull out this diagram and I tell people, be thankful you didn't do this hike 30 million years ago. We'd still have 2 miles to climb on out if these rocks were still here. And those rocks you see above that red line, they are already gone from the Grand Canyon. You got here too late to see those rocks at the Grand Canyon. So let's just erode those rocks away. They're gone now. And this is what we have at the Grand Canyon. Now, for those of you in this field trip, when you were at Arches and Canyonlands, you were looking at rocks in this section of the stack, and all of the Grand Canyon rocks were still in the subsurface in those parks there. Tremendous story here. Here's Grand Canyon's sequence of rocks, and we can identify these in 3 simple sets. In the green color here, we have the Vishnu basement rocks. These are the very, very old igneous and metamorphic rocks. Then in red, we have a tilted package of sedimentary rocks called the Grand Canyon Supergroup. And by far, what most people see when they look in the walls of the Grand Canyon are these flat-lying layers that were deposited during an era known as the Paleozoic. And again, if you want to simplify things for people, all you need to do is you just remember there's 3 main groups of rock. So if we look at the Vishnu basement, you have to go to the bottom of the Grand Canyon to see these rocks. I encourage you to come back sometime and do that. If you can't, this is what they look like down below us near Phantom Ranch, a beautiful 1,000-foot deep gorge of schist and granite that forms the inner gorge of the Grand Canyon. And here you see another view of it. The Colorado River has sliced down through these very ancient rocks, and here's the upper Paleozoic layer sitting above them there. What geologists can do, and this is what is in the book, Ancient Landscapes of the Colorado Plateau, is you study a layer like the Vishnu schist in many different places across the plateau. These rocks have been studied in various places, and you can put together the paleogeography. And I'm going to show you a few maps that have the outlines of the 4 corner states. You can recognize Arizona, Utah, Colorado, and New Mexico. That red dot is the Shrine of the Ages Auditorium where we are right now. And this blue color here represents ocean water. The important story for the Vishnu schist is that this was a long island chain of volcanic edifices that was drifting towards the edge of North America and collided and added real estate to our continent. And when that happened, these layers of shale and sandstone were folded and bent deeply down into the earth, where they metamorphosed into a rock called schist. Here's the Grand Canyon supergroup, these tilted sediments right here. They're only found in about 10% of the Grand Canyon. You can mostly find them in this part of the canyon by looking for this very bright orange layer called the Hakatai Shale. You can see that they're slightly tilted there. These are the only places where we see the Grand Canyon supergroup rocks. The best place to see them is from Desert View, Navajo Point, Lippin Point, or Moran Point. But just below the South Rim Village, we have outcrops of it, and then other isolated outcrops here. Most of these rocks were eroded away before people got here. And here's the paleogeographic map. I should mention that this abbreviation, capital M, small a, stands for mega annum. And that's an abbreviation for millions of years ago. Look at how long ago this happened, 1,100 million years ago. And these shallow arms of the sea were coming up here and depositing the Grand Canyon supergroup. And then finally, the Paleozoic strata, the upper 4/5 of the canyon walls. These are the rocks that most people notice. There you can see them beautifully highlighted with the snow that we're hoping to get this winter. Every horizontal line you see in the walls of the canyon, or actually any sedimentary rock on Earth, that used to be the surface of the Earth. And rivers or dunes or shallow seas were spreading that sediment out by gravity and causing these layers of rock to accumulate. I'm just going to show you 3 of these maps for 3 of the 9 formations. At 525 million years ago, a giant beach existed on the western shore of North America and extended all the way up into Canada, leaving behind layers of sand, which we now call the Tapete Sandstone. If we move up to 340 million years ago, that light white color that you see is actually a pale blue. This represents shallow marine water when most of the Southwest was inundated with this seawater. There was only one small piece of land that was sticking out right here in New Mexico and eastern Arizona. And when we go into the red wall limestone here in Grand Canyon, you see fossils of corals, sponges, bryozoans, and brachiopods. And then this deposit, the Coconino Sandstone, it's very famous. It makes this white bathtub ring in the walls of the canyon. This is deposited in huge Sahara-like dunes, and that's what this yellow color represents here. This yellow color represents wind-blown sand that was blowing into the Grand Canyon region. Think of all these different environments you've seen. All these different rock formations represent times when the environment was much different here. If we look at the big picture during this time, this is the giant supercontinent of Pangaea. You might be able to pick out the shapes of some of the continents there, but just in case you can't, I'll put names on them right there. Just think, we could have taken a trip from Grand Canyon and we could have gone all the way over to the Appalachians and visited Europe or Africa or Antarctica and never have to cross a body of water to do that. Of course, all these continents are fragmented now and they're in their modern positions, but 270 million years ago, this is what our Earth looked like. Well, that's the first part of the story. That's making the rocks. We've taken hundreds of millions of years, even billions of years, to make these rocks. And now what we want to do is we only want to talk about the last 70 million years. The Grand Canyon can be no older than 70 million years because that was the last time the ocean was here and rocks at sea level were being deposited here. In 70 million years, the landscape has been uplifted to its present elevation. And there's just a couple of basic ideas before we start this. Without the Colorado River, there could be no Grand Canyon. The Colorado River is responsible for the Grand Canyon. However, prior ancestors to the modern river could have carved some portions of that canyon. And this is where some of the modern debate begins as to what actually constitutes the beginning of the Grand Canyon. Other elements of erosion help to shape the canyon. It's the side canyons that give the Grand Canyon its width. And I'm going to show you a graphic about that. And the best age estimate for the canyon is about 6 million years ago. Now just keep in mind that date, 6 million years ago, specifically refers to the age of the modern Colorado River. There could have been some portion of the depth of the canyon or some parts of the canyon that were cut prior to that time. Here's a graphic that'll show you how the side canyons help to widen it. You can see the Colorado River down here at the bottom of the Grand Canyon, the south rim located here, and 10 miles away on the other side is the north rim. And sometimes people wonder if maybe the Colorado River was wider in earlier times and it meandered through here to carve out this big space. No, the width of that blue bar right there represents the width of the canyon that was specifically carved by the river. And the red bar represents the erosion of excavation by the side canyons running down into the river. Most of the space we see is carved by the side canyons. And that leads me to tell you about if water can really help to carve canyons. It certainly plays a role in it, but it turns out that water can't carve through solid rock. Water doesn't have the power to do that. It might polish a rock. In rare instances, it might pluck away at rock. But to carve the whole Grand Canyon, it probably doesn't. And one of the earliest observations when geologists were first trying to figure this out was that maybe the sand and the silt that's in the Colorado River would run over the bedrock and then it would slowly abrade the channel through millions of years. But it turns out that when they studied the bed of the Colorado River, they found that there was 75 to 100 feet of sand and gravel sitting on the bedrock, meaning that when floods came down the river, the bedrock wasn't even exposed to erosion. An incredible insight when they found that out. And so it turns out that what happens is water is just the facilitator of erosion. These are the guys that do the cutting right here. Look at these giant boulders. And when you get huge floods that come down, floods that people have never seen because they only occurred in the Ice Age, you can get boulders the size of this room rolling down the river channel, and they physically pound the bedrock channel and carve it out for itself. Did you know that if you had a time-lapse movie of the Grand Canyon forming and you watched this 70 million years in the movie, you'd probably see parts of the movie where the canyon's actively getting deeper and wider, interspersed by periods of the movie where it looks like it would just be sitting there and not much is happening. It doesn't happen at a same average rate through time. It depends on the amount of runoff. One of the ways we think the Colorado River came to look the way it does is by a process known as headward erosion and stream piracy. You can see a sluggish river over here labeled A and a steeper gradient river here labeled B. They are separated by some space in between, but you can see that the steeper gradient stream is always lengthening its channel in the upstream direction. And eventually it captures that river system right there. And after this integration event, then you start to get a deep canyon that is cut. We do not integrate the river in a deep canyon setting. We integrate the river in a low relief setting. And I've created this graphic for you here tonight to show this process in action. And if we want to think about the last 6 million years, what we have to do is we have to remove the Grand Canyon. So there, through the magic of Photoshop, I have taken you back prior to 6 million years ago. There is no Grand Canyon. And there's two rivers prior to 6 million years ago. And some geologists believe that one of the rivers, called the ancestral upper river, may have been flowing in that direction towards freshwater lakes in Utah. And then there was a second river called the ancestral lower river, and it was flowing from right to left in a course like that. And you'll notice that there is a gap between the two rivers right there. This is where we are seated tonight, right in this area. But because this river right here has a steeper gradient, it's lengthening its channel up towards that other river. And watch it lengthen its channel right like that, and then we get a capture point right there. And at that point, once it gets captured, then the water starts to run down, and that's what the green color is right there. That is the modern Colorado River. Notice that the Grand Canyon hasn't formed yet. Now that we've integrated the river, we've got enough water moving through that we can start to deepen this canyon. And here comes the deepened canyon, just like that. This is probably one of the most popular theories on how the Colorado River came to be, is by headward erosion and stream piracy. It's safe to say that I think all of us are here tonight because we love the Grand Canyon. But let me tell you that it hasn't always been this way. And it turns out that it was not until the Grand Canyon was understood geologically that people could appreciate it aesthetically. In fact, the first Europeans that came to look at the Grand Canyon, they had nothing complimentary to say about it. And all the conquistadors and explorers and miners, all these guys came to the Grand Canyon once and never came back. They didn't have anything complimentary to say about it. And I have a few examples of this. The very first people of European descent to see the canyon was the Coronado expedition. Look at that. It was less than 50 years after Columbus came to the New World, and Spaniards were already in New Mexico and Arizona. Here's the route of the Coronado expedition, and they sent a party over from the Hopi Mesas to the Grand Canyon to look and see if they could get resupplied by ships. And in the journal that they wrote, from the top the men could make out, apart from the canyon, some small boulders which seemed to be as high as a man. Those who went down and who reached them swore that they were taller than the great Tower of Seville. So think about it. In Spain, they didn't have any landform like the Grand Canyon. They didn't have anything to compare it to. And so this is what the Tower of Seville looks like today. Back in the year 1540, it was about 282 feet tall. Here's its Moorish incarnation there. And so what I have done is I have taken this photograph right here and I have made it down to size and placed it in the Grand Canyon. The Tower of Seville is in the Grand Canyon there. And if you can't see it, there's the Tower of Seville. In fact, just for fun, let's put 6 towers of Seville inside the Grand Canyon. And you can see that these Spaniards really were out of their league, if you'll pardon the pun, to notice what the Grand Canyon really was. And this went on for the next 236 years. Nobody of European descent came to the Grand Canyon for 236 years after the Coronado party. And there were other Spanish expeditions that came, but they had equally unflattering comments about the Grand Canyon. This is the first American to come to the Grand Canyon. He was a fur trapper in 1826. This is what he thought of the canyon. On the 28th, we reached a point where the mountains shut in so close upon the river that we were compelled to climb and travel along the acclivity with the river still in sight at an immense dip beneath us. It is perhaps this very long and formidable range of mountains which has caused the country of the Red River to have not been explored more thoroughly by Americans. A march more gloomy and heart-weary cannot be imagined. After 14 days, we arrived where the river emerges from these horrid mountains. You know, these guys wouldn't have come to this lecture tonight. They would have heard about something about the Grand Canyon. They wouldn't have come. The last of the unflattering comments actually comes from an expedition in 1857, Lieutenant Joseph Christmas Ives, and he's immortalized by his least prophetic view of what the future of Grand Canyon would be. They first traveled on this steamboat up the lower Colorado River, and when they got to where Hoover Dam is today, they started to go overland. And Ives was writing in his journal, and he wrote this: "The region is, of course, altogether valueless. It can be approached only from the south, and after entering it, there is nothing to do but leave. Ours has been the first and will doubtless be the last party of whites to visit this profitless locality. It seems intended by nature that the Colorado River along the greater portion of its lonely and majestic way shall be forever unvisited and undisturbed. I think you guys are part of the first 5 million visitors to Grand Canyon. This year it might go over 5 million visitors. And so Ives did not know what he was talking about. He wrote many uncomplimentary things. Here's one more: the solitude, the stillness, the subdued light, and the vastness of every surrounding object produce an impression of awe that ultimately becomes painful. Now, he did have a few complimentary things to say about it, but it's safe to say that a geologic perspective was really needed to understand this. Nobody who came here for these 300 and some odd years understood the significance of Grand Canyon. And how ironic that the geologic perspective would come from a member on Ives' own party. This man right here, John Strong Newberry, was in the saddle next to Ives, and he was the first geologist to see the Grand Canyon. Look at how he reacted to the exact same landscape. Though valueless to the agriculturalist, dreaded and shunned by the immigrant, the miner, and even the adventurous trapper, the Colorado Plateau is to the geologist a paradise. It has the most splendid exposure of stratified rocks in the world. So you guys that are in this geology class, when you're signing up for classes, you're going to sign up for the guy who calls it a profitless locality or the guy who calls it a paradise? I'm going to go on Newberry's trip here. He's having more fun. Newberry was the first person to recognize that the Grand Canyon was formed by the exclusive action of water. And this is actually a colorized version of his cross-section that appeared in his report to Congress in 1861. And he noticed that the strata were conformable no matter how wide the Grand Canyon were. They were not offset by faults. And so he postulated in 1857 that the giant hole in the ground was actually carved by water. And that was a huge insight in 1857. And then, of course, John Wesley Powell. We've all heard of John Wesley Powell. He was the first person to go down the river, but he also was a trained geologist. And he did this 101-day trip in 1869. He was mostly in a race for survival when he was going through the Grand Canyon. But one of the things his men complained the most about him was that even though they were almost starving to death, John Wesley Powell was still giddy about the geology. Listen to what he wrote coming through here. We continue our journey, gliding along through a strange, weird, grand region. The landscape everywhere away from the river is of rock, cliffs of rock, tables of rock, plateaus of rock, terraces of rock, crags of rock, 10,000 strangely carved forms, rocks everywhere with no vegetation, no soil, no sand. In long, gentle curves, the river winds about these rocks. That sounds like paradise to me. I want to go on that trip. And these are the kinds of rocks we're talking about. This is Grand Canyon's Esplanade platform, located in the western Grand Canyon. And for people from back east to see these kinds of landscapes, they had no experience with landscapes like these, and geology is laid bare right here. Well, these are 8 of the geology all-stars. I'm sorry there's no women in this group, but up until about the 1970s, it was deemed that women couldn't be geologists. I think as we're seeing in the field trip here today, women make great geologists. In fact, in many colleges, women are majoring in geology more than men are. But during the first 150 years of study of the Grand Canyon, these are 8 Grand Canyon all-stars who contributed original theories to how the canyon and the Colorado River formed. And interesting to note, 100% of the conquistadors, the explorers, and the miners in the exploratory era never returned. 100% of them. 100% of the geologists who encountered the Grand Canyon came back again and again. It's fair to say that if you're a geologist and you look at this hole in the ground out here, you're looking at paradise. In fact, I often joke with people on my trips that in a previous life, I was a petroleum geologist in Houston, Texas, and when I died and went to heaven, this is what heaven looks like to a geologist. Well, here's a graphic summary of Grand Canyon's geology. This shows you in pictures how all the rocks and the big hole in the ground formed. And you're going to see the numbers of millions of years ago in the upper left. And between 2,000 and 1,800 million years ago, you could also say 2 to 1.8 billion years ago, we had these volcanic islands that were located out to sea, sticking up, and they were moving by plate tectonic processes to collide with the edge of North America. And in this environment right here, we created the Vishnu Schist. And when these island arcs came into North America, they created what we call the Vishnu Mountains. There were no people around then to give these mountains names, but this giant mountain range was created up here. And from about 1750 to 1250, these Vishnu Mountains were upthrust in this region and then eroded away. And here's where they're going to erode right there. That is a future unconformity. That's how far down the erosion is going to go. And the amount of material that covers that surface is postulated to be between 10 and 15 miles of rock. 10 to 15 miles of rock was eroded off of here during a 500 million year period. And when we remove that 10 to 15 miles, this is what it looks like. And then on top of that surface is where these now tilted Grand Canyon supergroup rocks are found. The thickness of these rocks is 2.5 miles, and that was deposited on top of the eroded roots of the Vishnu Mountains. And then those rocks were faulted and pulled apart, tilted, and it was on that surface right there that a second period of erosion came, the second great erosion. You can see the line going across. Only these faulted wedges remain in the Grand Canyon landscape. And then it was on top of that surface, known as the Great Unconformity, that the Paleozoic rocks of the Grand Canyon were deposited. It took about 225 million years for those rocks to be deposited there. And as I told you, on top of the Grand Canyon rocks, we had 5,000 to 10,000 feet thickness of other rocks that were deposited on top of them. This is the 3-mile stack of rocks. You can see the supergroup buried deeply there, the Vishnu Schist and the Zoroaster granite there. And the last part of the step, right there, we create the Grand Staircase, we create the Grand Canyon. The Grand Canyon has formed by this extreme erosion in this arid environment. Enjoy your time in this timeless landscape. I'm certainly happy to entertain any questions. And I know that Cherie is out there with copies of my books, and if you'd like to have a signed copy, I'd be happy to do that for you. Thank you very much for coming out tonight and celebrating Earth Science Week. Any questions? Anybody have a question? Must come from a geologist. Yes, there you go. Okay, so the question has to do with the layers of rock that I've spoken about that we assume were here at the Grand Canyon, still present in Zion and Bryce. How do we know that they were here? One of the reasons we know is at the very bottom of that stack is still found in 2 places close to Grand Canyon. And whether you drive out the East Drive towards Desert View or south towards Williams, you're going to see these 2 mountains sitting on top of the Kaibab limestone of Moenkopi and Chinle Formation. So we know at least that those 2 layers were there. But the other thing is that it's just immediately east of Grand Canyon where we see this thick stack of rocks. We can also see them north of the Grand Canyon. And believe it or not, if you go to Las Vegas, west of Las Vegas, there's a place called the Red Rock Conservation Area. And all of these rocks are there as well. So the Grand Canyon is surrounded on 3 sides by these rocks, and they don't change from one place to the other. So since they're very continuous and alike in those 3 different places, we assume that they used to be covered here. There also is a very detailed technique that geologists are now using where you can look at little tiny apatite crystals that are left in Grand Canyon's rock, and they give a record of that crystal's cooling history. So when all these rocks used to sit here on top of Grand Canyon, that means the apatite crystals in Grand Canyon's rocks were deeply buried and they were hot. And that cooling history can be recorded in these apatite crystals. So we're coming up with even more ways to verify that these rocks used to be here. And that's a damn good question. Thank you. Anybody else? Yes. The question has to do with that chart that I showed you with the ancestral upper river flowing north into lakes into Utah. What is the evidence for that? The evidence for that does not come from lake deposits. The evidence for that would come from the fact that we have lake deposits that are older, not related to what that river might have been, but we know that for at least 40 million years that rivers were flowing from southern Arizona onto the Central Plateau. From 70 million years to 30 million years, there's lots of evidence throughout the West that rivers were flowing in that direction. And we actually do have lake deposits that are that age. Next time we have evidence for rivers is at 6 million years ago. So there's about a 24 million year period where we don't know what the rivers are doing. But we can assume that for part of that 24 million years, the rivers continued to go north. For another part of that 24 million years, they had to be in the process of turning around, and for part of that, they had to be going south. So it's just a matter of connecting previous histories that are well accepted with postulating what was going on there. Now, when that theory was first proposed, they actually had the ancestral upper river going in the opposite direction than I showed it, that it came out of central Utah and was going into the Rio Grande and the Gulf of Mexico. But about 15 years after they proposed that theory, that was shown that that river could not have gone over the Continental Divide. So we were still stuck with the idea that seemed to work, but we had no place for the river to go. And I must admit, that idea that it was going into lakes is mine and a few other geologists, and that hasn't been fleshed out by everybody yet. Well, one competing idea would be that the river never had to be integrated. This was John Wesley Powell's idea, that the river we see today has always been in that configuration. But some of the geologists who believe in that idea, they think that the early parts of that river configuration, the river was going in exactly the opposite direction it goes today. And there was a theory presented about 5 years ago by a geologist from Caltech. He actually had the Grand Canyon being carved to within a few hundred meters of its present depth by a river in the canyon that was going the exact opposite way it goes today. So either you're a river integrationist or you're not. And then if you're a river integrationist, there's 3 ways it could be integrated: headward erosion, karst collapse, or basin spillover, where you get a giant lake on one side of the canyon and it spills over a low rim of the lake basin and then begins to flow in that direction. So I'm an integrationist. I believe that there were 2 rivers. I think rivers are just like people. They have histories, they have evolutions, they change through time. I would say most geologists probably are integrationists, but then geologists sort of diverge on what was the process that integrated it. And for many years, headward erosion was the favored theory. Basin spillover is an up-and-coming theory that has at least been proven for the lower river. And there's one geologist from the University of New Mexico, Carol Hill, who proposes that caves collapsed. Subterranean river water was in the Grand Canyon area. When the caves collapsed, they created a surface drainage. Those would be the 3 ways that could be alternative to headward erosion. Yes? Well, what started to wash it away is when the whole Colorado Plateau began to be uplifted. So when you bring rocks above sea level, you're placing them in an environment now where water running off the land can incise down into them. When people from back east hear that the Colorado River has a very small volume of water compared to, say, the Mississippi or the Missouri or the Ohio, they always wonder, how come we don't have a Grand Canyon in Ohio or in Minnesota? And the answer is they don't have the uplift of the rocks. At Minneapolis, it's only 700 feet above sea level. You can't carve a mile-deep canyon into a landscape that's only 700 feet deep. So what happened to this 5,000 to 10,000 feet of sediment is that the plateau was being uplifted, and the youngest layers that were at the top were the first ones to be removed off. And it turns out we have really good evidence that the first rivers, when the ocean left for the last time 70 million years ago, the first rivers were going from where Phoenix is located today, across the Grand Canyon region, all the way into Utah and Colorado. And until the Rocky Mountains came up, that water was going into the Gulf of Mexico through the ancestral Mississippi system. And some of those rocks that you're referring to, some of that sediment is sitting in the Gulf of Mexico. And then when the Rocky Mountains came up, beginning about 60 million years ago, it blocked off that flow, and this is when we get the freshwater lakes in Utah. So the water is still coming out of the Phoenix region, but it's being ponded on the Colorado Plateau. And rocks in the Grand Canyon region are supplying dirt to that system, and that's part of that 10,000 foot. And then as we continue to uplift the plateau, we're going to remove some of the lake beds, we're going to remove more rocks here. Essentially, you got here at just the moment in time when most of this 10,000 feet is gone. There's two little mountains on either side of the park here that you can see remnants of it. Thank goodness for that. If we'd have gotten here in just another 200,000 years, we might not ever see that. That's where some of that stuff is gone. Of course, now it's all going down to the Gulf of California. Temporary storage in Lake Mead. Very temporary. Well, you guys, oh, okay, I'll take another one. Yeah, she's asking about the lava flows and if they actually did block the river and if a reservoir piled up behind these dams. It's very, very likely that it did. And there's anywhere between 13 and 17 remnants of dams down in that part of the canyon. This is an area that's currently being studied intensely for the volcanic history. And somebody's actually spent his whole early career mapping this. And it turns out that if these lava dams were stable, and they may not have been, but if they were stable, it would have taken thousands of years for some of these reservoirs to fill with water. In fact, there's one dam that's been calculated to have stood 2,300 feet above the modern river corridor. Imagine a dam 2,300 feet high. Glen Canyon Dam is 700 feet high. 3 times higher than Glen Canyon Dam. It would take 2,200 years for that reservoir to fill with water. And if you look at the contours at that elevation, the water would have backed up close to Moab, Utah. And down below us here, there's a campground down there called Indian Garden. Indian Garden would have been under 300 feet of water. And everything below that totally inundated with water. Now let me just take your question a little farther. Imagine if you'd been camping on the rim of the canyon when this lava dam was forming, and you could see red hot lava at night spilling down the walls of the Grand Canyon. Imagine the steam coming off when the red hot lava hits the river. And then imagine you're camped up there and you can see this giant lake inside the Grand Canyon. It's very possible. And then imagine you happen to be lucky enough to be camping there the night or the day that the reservoir totally fills to the brim and starts to pour over the lava dam. Then you'd have a 2,300 foot waterfall in the Grand Canyon. And of course, once the water starts pouring over the lava dam, it's going to start to erode out the dam. Imagine if you had been there when the lava dam broke. And recent research has shown that on at least 5 different occasions, 5 of those lava dams failed catastrophically, all at once, and all the water was let out. And we have deposits down there, they're called catastrophic flood deposits, that sit 600 feet above the modern river with boulders in them the size of this room that were laid down when these floods. They estimate it took 36 hours for one of these reservoirs to totally drain. This is how fun this stuff is, and the deeper you get into it, the better it is. Yes? Imagine the Colorado River doesn't flow. How does it become canyons? Well, one of the ways you can get a canyon without a river is to have a rifting area where you start to pull the Earth's crust apart, and you can create a long linear hole in the ground. But typically what's going to happen is that rivers are going to take notice of that, and it won't be too long before a river starts to flow down that rift. And that's what happened at the Rio Grande River in New Mexico. The crust in New Mexico was being pulled apart, and a long, narrow rift valley formed, and the Rio Grande was nearby, and it saw that rift, and it said, I'm going to go there. So that's one way you can have a canyon without a Colorado River, but you really can't have a Grand Canyon without a Colorado River, unless you become the first person to figure out how. And I hope you are that person. Well, I'll gladly take other questions if you want. Thank you again for coming out tonight and supporting Grand Canyon National Park.